Our next speaker will show us how to create and connect the metaverse using Nvidia Omniverse. Taking us through this topic is Raghu Ganti, ProViz Omniverse, Nvidia AI Enterprise. Raghu is a sales leader with over 17 years of experience guiding and transforming businesses across APAC in the auto, aero, medical, and industrial equipment industries using technology and analytics. He leads the ProViz and Nvidia Enterprise software.
Welcome, Raghu, and over to you.
Great, thanks. Thanks, guys. Hi, good evening, good afternoon, everybody. I'm Raghu, and yeah, let's get started about seeing how to create and get started with Metaverse, right? AI and Metaverse or visualization is in everything that NVIDIA does. Here's a brief video of
I am an explorer.
All the pieces of technology
traveling
that we
across
embrace.
The Atlantic to unlock its mysteries. And back in time to understand the origins of the universe. I am a visionary, bringing sharper focus to researchers. And brilliant clarity to surgeons. I am a healer, making treatments as unique as every patient. And giving new life the chance to thrive. I am a guardian, looking out for dangers around us. And in the depths below. Healthier, more sustainable crops. Bringing them to market faster. And preparing them for the table. I am a creator. Building virtual worlds to help robots learn faster and make our connections stronger. I am even an avatar, and you can ask me any question.
Who made this song?
Ava used artificial intelligence to write this song, and it was recorded by the London Symphony Orchestra. I am AI, brought to life by Nvidia, deep learning, and brilliant minds everywhere.
So you've seen a glimpse of all the pieces of technology that are possible for this world, the virtual worlds that we are trying to create, right? And this is primarily to enhance our real worlds, as we call it. But what exactly is a metaverse? It's nothing but an evolution of 2D internet. So because you've seen you embrace or use your 2D websites and so on, this natural extension into a 3D world is what we call as metaverse. And these could be independent, and these will all be connected together. And of course, we at NVIDIA using AI and Omniverse are helping people get started with it. But what there are, I mean, I think I should lay the context of what exactly are the rules for metaverse, right? It is a concept. People can say it's not a real place or anywhere that you can literally go and do something, right? And then it's a network of networks as we look at it. So it's composed of many different worlds that will be connected all across. And of course, as I previously mentioned, it's just a natural extension of our 2D way from 2D to a 3D world. And of course, it's open and nobody owns it, just like your 3D, our internets. Nobody exactly owns this 2D worlds or our metaverse as such. Right. And then, of course, as just like you need web developers, content creators, you need the same for people who need to create these metaverse or the 3D worlds as we speak. And these worlds are going to be in hardware independent, and users need to be able to get in using any device, any way possible, not just with HMDs or the VR headsets and so on. So you should be able to rope in, get inside and out using either your laptops, tablets, or any other devices. And it should be open and interoperable, just like you can get on from your cell phone, a website on your cell phone into a website on your laptop, or vice versa, or on your TV. It should all happen seamlessly. And you might be wondering, where are these? But you might say, hey, the metaverse applications are already there when you look around yourself. When you look at content creation, so you already experience things in 3D fashion. Or when it comes to AR, where people are already deploying applications in augmented reality. Or when it comes down to either perception engines and training in the virtual world using this synthetic data. Right, virtually, you could literally see all applications of metaverse already there across many different industries, be it climate predictions, be it autonomous vehicles or factories of the future, digital twins or 5G network propagation evaluations and so on. But mind you, this metaverse actually requires specific sets of technology. One, it has to be based on open standards. Why? Because nobody owns this metaverse, or nobody should own this. It should be everybody's. Everybody should be able to contribute and be part of that. And then, of course, these worlds should be scalable, because some of the worlds would require to be precision time. That is, when you have a digital twin where it represents exactly what's happening in the real world, in the virtual world, then you need to have precision timing systems. And then these worlds should be real time and physically accurate, because these are worlds that we represent. Of course, some worlds will not have to be accurate physically, because they need not be obeying the laws of physics, but most of the worlds that we build across, right, need to have all the physics that we encounter on Earth. And we also believe these worlds will also need technology. You can't create these thousands different 3D assets and so on, or these worlds using hand, or people cannot sit and create it. Of course, you can refine it, but you would definitely leverage AI to be able to create these worlds in an instant or a jiffy. And very coming to these open standards, so what we believe is something called as an USD. This was developed by Pixar and open sourced in 1995. And this is based on a unique concept called as layering. So, and then it is extensible and it is open source. So people can start creating their assets and connect their existing design creation tools. You don't really have to change anything, but all you need to do is connect your data set to USD, and you're able to create these virtual worlds. And of course, since it's extensible, if there is a feature that's not available, you can always create it, or you can develop it. And of course, there are many other industrial players that are contributing towards creation of this open standard. But what is so unique about this USD format? It's basically sparse and it's non-destructive. So multiple people can collaborate and work on the same engine at the same time. Doesn't matter where you are. You could be spread across the globe, across multiple countries or multiple time zones, but all of us can collaborate at the same time. And as I said before, it's extensible. So you can literally plug in your own data set or your data formats and bring it into these metaverses, because there is very likely that at some point of time, you would have unique tools and pipelines where your data set is unique to your own environment. But if you want to bring it in to this virtual world, you should be able to. And then you should be able to solve or store these across different locations. And this should be file system agnostic. And then, of course, for people to be able to render these worlds in a massive scale, you have generalized pipelines. As long as it's Hydra-based renderers, you could literally stream across and render these massive worlds. We are talking about cities or, even planetary scales. Nvidia has been investing quite a lot. I mean, of course, there are other industry players as well that are contributing towards it. And as you can see, since 2020, ever since we started working on Omniverse, we've been helping out the world developing or enhancing the capabilities of USD. So, of course, be it in the terms of material definition language, or be it using USD physics, accurate physics, be it CFD, or finite element analysis, and so on. And then we have also introduced geospatial coordinate systems inside that to be able to tag things, and CAD converters to be able to bring in your assets, doesn't matter what format they're in. And of course, we are also talking about integrating it with real-time sensor data so that you can have accurate representations of these digital twins and worlds as we speak. So we've built Omniverse to actually help us so that you could create these multiple metaverses or virtual worlds together, right? Be it when you want to create your own custom 3D design scenes, so or be it for operating it. So you could look at it on two different scales, where on your left-hand side, you have people that are creating these content, and these could be, and it could be any different kinds of data, because you could have CAD designers, you could have creative designers, you could have architects, and so on. Or it could be people on the factory floor who have robotic information or manufacturing information. And the data can be used for multiple different use cases, be it for planning of the factory floors, or be it the ergonomics, how human machine interactions, or even for robot gym, so that you can replicate or you can tell a robot virtually, even before you deploy it, how it has to behave in the real world, thereby eliminating any sort of errors inside that. And once you have aggregated all of this data, you could infuse that with AI, materials, lightings, physics, thereby making sure that this virtual world exactly represents your physical world asset. And of course, these applications are widespread across. Where do we see people using them? Be it your 3D content, 3D applications, or design of goods. So anytime you see open up any e-commerce site, you would have already seen a 3D model of things, and so on. Or be it for digital twins, or and these digital twins could be on a product scale, or city scale, and even to a planet scale. We are working on a digital twin of Earth where you could predict the climate changes as it happens, right? And this is a very super big effort that requires a whole lot of people from different countries collaborating. Or we could also use the same worlds. Actually, people are already using them to train their AI models or perception engines, be it in the terms of either robots, or be it autonomous vehicles, or computer vision networks, all of these. And of course, I did hear some of the panelists earlier talk about avatars and so on. These are already there. People are already deploying them. And of course, these could be AI operated, or these also, it could be myself. When I keep talking, it could be an AI, so that it can be agnostic of whom am I speaking to. And we'll see quite a bit of this. So first and fundamental thing for any metaverse that you want to create is to have 3D content. right? So how do you go about looking at it? So people, these can be spread across different locations, and of course, and using multiple tool sets, whatever they're using. But all of these guys need to be collaborating at the same time to produce these massive metaverse or virtual world, as we can call it. And of course, infusing that with AI will really help speed in things and help automate tasks. Let's see how some of these technologies in play.
3D design is a complex team sport with different artists, apps, and hardware often working in different locations. With Omniverse Cloud, it's much easier. Using Nvidia RTX PCs, laptops, and workstations, designers can work together in real time. And if you don't have an RTX computer, you can stream Omniverse from GeForce Now with just a single click. Let's watch as an architectural design team reviews a project using Omniverse View in a web conference.
All right, right here is the 5th floor patio.
To get a better feel for the lighting, let's see what the space looks like at noon.
Sure.
It's a little sunny. Let's make some adjustments to the trellis.
1 sec. How's that?
Much better. Let's see if we can get Teresa on.
Yep, sending that link now.
Hey, you two.
Hi. So we did a sun study at midday and decided it needed more shade. What do you think?
Yeah, that looks great. But I still feel like it needs a little more. What if we add some trees?
Yeah, let's get TJ to help with that.
Hi, how can I help?
Hey, TJ, can you add some medium-sized trees in planters near the tables?
Sure, let me add that for you. How does this look?
Nice. But TJ, can we vary the trees, say size and type?
Okay, here you go.
Hey, TJ, let's go to the bar and see what it looks like at night.
You got it.
Yeah, that looks great. I'll send the link out for approval.
Not all worlds will be created by hand. It's simply not.
See you in Omniverse.
It's simply not possible for people to keep creating these huge worlds by hand, right? So you have to be smart enough to leverage some pieces of technology that can literally help you recreate these worlds super fast. And of course, be it using some of the technologies like NERF or using technologies like neural reconstruction. So these are some of these latest technologies that can literally help you recreate these virtual worlds on the fly that look exactly like our physical worlds.
We are supercharging DriveSim with a neural reconstruction engine to enhance simulation with AI and data captured by the fleet. In a matter of minutes, the neural reconstruction engine can reconstruct a full 3D digital twin of a recorded drive from sensor data. Objects are harvested and reconstructed using AI. Large-scale asset and scene libraries are created from real-world drives. The reconstructed scenes and assets are loaded into Omniverse and are ready to use in DriveSim. Using NVIDIA Drive Map, we can place dynamic objects, such as vehicles, as well as pedestrians. Recorded data can now be turned into fully reactive and modifiable simulation environments for closed-loop testing. New scenarios can be authored using synthetic and harvested scenes and assets.
For training your perception
We
engine.
can generate synthetic ground truth data to train perception networks. These authored scenarios can be used for end-to-end testing, including challenging scenarios. NVIDIA DriveSim, powered by Omniverse and AI.
So as you saw, these are different pieces of technology that will help us create these worlds, right? But again, there's still some other piece missing because these are all static worlds. This could be, if you look at it, this could just be like any other video game. right? But again, coming down to replication of our physical world, there is some a subtle element that's missing. That is, you still need to be able to connect some of these sensor data to make these alive. So if you are able to add in all, because you're now able to visualize things as realistic as possible, that is a cloth would look like a cloth, a tree exactly like a tree, and with all the reflections, a glass, metals, and so on, because it's we use real-time ray tracing, RTX technology, which we have perfected over the past 30 years. And of course, adding physics to this, because anything that moves has to follow the laws of physics on Earth, right? Newton's laws. So including that. And then, of course, using AI to recreate and enhance these worlds. And of course, when you get the sensor data from the real world, that is physical data, these could be from human interactions, or it could be sensors, or it could be any sort of controllers. So you will have a perfectly synchronized digital twin. And this is where we want, or NVIDIA is looking at enhancing the enterprises. The next one is where I would like to show you how a particular rail network in the Europe is using some of the pieces of technology. That is because you can't look at them individually, but you'll have to get started with the 3D world creation. But yeah, let's have a look at how Deutsche Bahn is trying to use, and of course, these are snippets of digital twins in action. A Deutsche Bahn here. Physics simulation, perception engine training, and this is a virtual world. Or RF planning scenarios on a city scale. Or a digital twin for customer experiences. Passenger movement and so on. Mixed reality, MR. Factory of the future from BMW. Digital twins are very critical for, because a digital twin in itself is a is called as a metaverse, right? If I take a digital twin of a city, it's a metaverse of the city. If I were to look at it, a digital twin of a vehicle, it's a metaverse, right? So everything it's a world of its own. But why is it so important? So digital twins are pretty unique in that they give you people or the enterprises with some sort of superpowers where you can literally jump into a particular location and then visualize what's exactly happening. So to give you a context here, so we have seen one of the largest design plant, right? When you're trying to create a construction or of an asset. So then this was one of the largest in the world where people literally, not everybody can move in. So we had people that could literally teleport using an VR headset into that particular location to visualize these worlds, as we call it. And then it can also give you a chance to go into the past and see what exactly has happened for the particular result that you're experiencing now. Was it the pressure in the valve was low? And so, and that caused this thing to slow down, or what exactly happened, right? Or you can also look into, if you were to give the same kind of throughput right now, what will be the output, final output? So it also gives you a tunnel to, or a portal where you could literally get into the future. Or it also gives you an opportunity to evaluate the different possibilities or the future outcomes and choose the best conditions that will give you the best possible outcome, right? So it makes you a Superman as we speak. And some of these are already there, some of the scales as we look at it, because you already have product digital twins, because you talk to anybody that manufactures, be it your iPhones or your cars, there is a product digital twin already there. We have people that are talking already about full-scale factory digital twins. I'm not just talking about the CAD models or just the visualization part. Or when it comes to cities, smart cities and city scale digital twins, there are a lot of cities that are looking at or already have started their journey towards it. And then, of course, you will have planetary digital twins as well. We are NVIDIA, together with its research partners, is already working on at least one of the models of Earth, where we are able to predict what will happen based on predict the different weather scenarios, so that you can optimize your what you call power production, or you're able to predict the extreme events, or you could even predict floodings, etc. So to enhance and improve the lives, right? So now we've looked at digital twins and how to create, how AI as well as humans help create these virtual worlds. And let's look at another piece of the metaverse, where everybody was talking about avatars. So these worlds will have people like us in the virtual world traveling across, or it could be NPCs, just what you see in video games. But they cannot be as dumb that you could just have a character that moves around, but rather it will have intelligence at a very high scale as we speak. And of course, these are not all that straightforward, because there are many different pieces of technology that go in, right? Be it, one is, of course, vision. It has to be able to see you and then respond to your facial features as well as expressions and so on. It has to understand. We are looking at text-to-speech and automatic speech recognition. That is, it has to understand what we speak as well as interpret what we are speaking. And then based on that, it has to be able to search for an answer and retrieve the answer. All of this is on the AI side. But there is also something that goes on to the visualization side, where it has to move or perform the gestures, the facial movement, the eye movement, and all of it, and the body movements, etc., all have to be synchronized with that particular action or the kind of answer that it's giving. That is, a sales bot or a sales avatar would be different from a concierge avatar, or it could be different from a teaching avatar. So you would need to have different kinds of gestures and so on. We at NVIDIA are already driving a lot of this using Omniverse, as we call it. We have a feature called as audio to face, audio to emotion, and audio to gesture. So with just a clip of an audio, it's able to predict how things move and your facial expressions and so on. All right, let's see some of these in action where they're putting it.
Interactive avatars are growing in popularity and use, from providing customer and sales support to marketing tools and teaching aids. But creating interactive avatars is very hard and typically requires expensive equipment, specific expertise, and time-consuming workflows. NVIDIA ACE is a collection of cloud-native AI microservices that make it easier to create, customize, and deploy intelligent and engaging avatars, built on any engine and deployable on any cloud. An interactive avatar needs to understand and communicate with you, from the more common text-driven chatbots that help users with site or subject-specific queries, to real-time, fully animated 3D avatars that can see and hear you. And ACE has all the necessary AI building blocks to bring them to life.
Hi, I am Violet. How can I help you?
This is Violet. She is a fully rigged avatar with some basic animation. To make her interactive, we use NVIDIA's Unified Compute Framework, or UCF Studio, to build a graph of microservices that we can deploy in the cloud. For Violet to be able to hear and talk to us, we include the Riva ASR and TTS components, and we use audio to face to provide the necessary animation. Each microservice component has color-coded inputs and outputs for easy connection and error checking to avoid incompatible connections. We then connect a food ordering dataset to handle customer orders and queries.
Do you have any low-calorie options?
I found these 4 options for low calorie. market salad, fruit salad, diet cola, and lemonade.
I'd like a market salad, please.
Okay, I have added one regular market salad to your cart. What else would you like?
Do you have any orange juice?
I could not find orange juices, but I found a similar item. One small lemonade is priced at $2.
I just learned about the lemon slice nebula today.
That's cool.
Please ask me about items in the menu.
Can I have one small French fries, please?
Now, let's make Violet smarter. The Tokyo Application Framework comes with a customizable pre-trained natural language processing model. However, we do want Violet to be able to answer questions that don't relate to food orders. To do this, we add a pre-deployed Megatron LLM microservice and update the inference model settings for open domain question answering.
Hello, I am Violet. Ask me anything.
What do you know about the lemon slice nebula?
The Lemon Slice Nebula is a planetary nebula located in the constellation Camelopardalis.
How far is it from Earth?
4,500 light years away.
Let's switch our avatar to one from another engine. For this, we'll use Unreal Engine 5 and MetaHuman to power Violet. All we need to do is go back to UCF Studio and switch the microservice output of audio interface from Omniverse to Unreal Engine. We then relaunch, and now we meet Ultraviolet. And she has all the same intelligent capabilities as the previous Violet.
Hi, I'm Ultraviolet. I'm a digital avatar. I've been brought to life by Avatar Cloud Engine, or ACE for short. Omniverse ACE powers my speech, animation, and intelligence. I can even answer challenging questions using the power of a large language model. Ask me anything.
So apologies, I think the video is lagging, but yeah, perhaps I can share some links later on post this. But you would see that these avatars would be in virtually a lot of different places, as we call it. These could be autonomous driving things on their own, where you can just deploy it and forget it. Fast food centers, or wherever there is a customer service, hospitals, banks, etc. Or these also could be part of the gaming worlds that we look at, where you are, if you are creating a metaverse for a real estate company and so on, you would not want it to be devoid of people, because every time somebody goes in, there should be some folks that would be there for you to interact if you want to add in some sort of gamification, right? Or if it could also be in some sort of web conferencing where we could literally replace myself with an avatar, which I already try to do it sometimes using audio to face, or anywhere in the healthcare industry where you want to hide bias or whatever it is, right? So to ensure that you're able to deploy these on a scale to provide the necessary services across. So to conclude, right, of course, these metaverses are already there. It's just the kind of application that you choose to, be it in the kinds of creation of these virtual worlds, environments, or goods, or be it in the terms of digital twins of the scale of industries or factories of the future, etc. Or even for that matter, if you go down to any manufacturing floor, there are already computer vision models that are there to help you either for defect detection or facial recognitions, etc. Or it could be avatars. Of course, we don't really see a lot, but we do see chatbots. The natural evolution of a 2D chatbot is a 3D avatar. So these are already there. So yeah, I'm happy to share across today on these different applications on how you could get started with it. And as I said, Omniverse is a platform for this virtual world creation, providing these different snippets of technology. Thank you.
Session. And thank you again for taking time out of your day to join us today.